Hey, welcome back to Mr. Music's Weather Whiteboard. I'm Mr. Music. Today we'll be talking about highs and lows. You look at any weather map, you're going to see a blue H or a red L on there for high and low. Let's dig a little bit deeper about what that really means and what the impact on our weather is, or weather predicting is. So first and foremost, I try to understand or put some common terms underneath each one of these and kind of piece this together, and what some relationships. And a lot of things on weather map and weather recording are very symbolic. And so with that in front, I hope you start piecing this together, help you remember things a little bit better. But let's talk about highs first of all. What is high pressure? High pressure is generally cooler air because it's cooler, it's more dense, so it's sinking. Because it's cooler, it's more stable. Think of something that's warm, more volatile, cooler, more stable. So it's stable. And because it's stable and cooler and sinking, it's generally associated with fair weather. And we'll get into it a little bit more in a second, but just while I'm putting this together, because high air with surface winds and under a high pressure system in the northern hemisphere will turn clockwise. So I'm just going to put this here, also known as anticyclonic. And you'll understand that a little bit more when we're done, but I just want to put that on the list. So therefore, with a low pressure, it's going to be warmer air. It's rising, generally more unstable, like my handwriting. It's poor weather, generally speaking, and the winds about a low pressure system, as we'll explain a little bit more, turn counterclockwise, also known as cyclonic in the northern hemisphere. So first and foremost, high pressure is cooler, sinking, stable, fair, clockwise. Low pressure, warmer, rising, unstable, generally poor weather or erratic weather, stormy weather, and winds about a low pressure turn counterclockwise. I'm going to drop a couple of images in here, and then give me a chance to erase the board and be right back. Okay, so let's take a look. Let's say, for example, here's the surface. And because of the sun's energy, and the sun is the driver of all our weather, provides all the energy for our weather. So UV, shortwave radiation coming in this area, heating this area up. So what's happening? As the area heats up, you will get an air mass. Let's say you get two of them. You get air masses that are rising. Now, you have to kind of visualize it a little bit more of in a three-dimensional, even though I'm only drawing it two. So you get air that's rising, hot air. So it's a little cooler over here, a little cool over here, sun putting it on here, for whatever reason. More clouds over here, cooler, clouds here, whatever the reason might be. All right, so you have rising air. So rising air. As we know in the troposphere, as you go up in elevation, temperature's cool, you're further away from the surface, which provides a lot of that long wave radiation. Boom, it heats up down here, rises, so it has to heat up the ground first, then rises. All right, so as it moves away from the surface, it cools. So it cools, spreads out. As it cools, colder air is more dense, it begins to sink, starts all over again. All right. And then you'll have another parcel probably over here at some point in time experiencing something directly opposite. I'm going to label these. So let's go back to here. So we have air rising. So if it's rising air, is it high or low? Well, it's going to be low pressure here. Because it's, I always say, I'll make that a little better. If it's rising, I always think of air pressure. This is thinking putting, if it's high pressure, it means there's more air stacked on top of you. It's low pressure, it's meaning air is being pushed up off or picked up off of your shoulders, if you will. So this is going to be an area of low pressure. Now we talked about symbolic. You'll see the low pressure will always be in red. Think of red as something warm. So a big red L, warm area, because it's warm, it's rising. So you have rising air. Now it comes up here as it moves apart. This is what's called divergence. So this is a zone of divergence. Divergence of air moving apart from each other and really almost like creating a vacuum effect as it moves away. Now here, this will just kind of repeat itself, but we'll jump over here to this one. Now here you have two areas coming together. That's an area of convergence. And now this air is sinking here. So if it's sinking and it's cooler, this is going to be an area of high pressure. So you kind of put the pieces together, is that you have low pressure, hot, warm, moist air generally rising. As it rises up, it expands and goes in different directions, creating an area of divergence. As it moves somewhere over here, and it's maybe not to scale, you're going to have convergent air coming together, coming down. This is going up. So as it's coming down, it's pushing down on you. It's cooler, sinking air, high pressure. So that kind of explains a little bit in two-dimension how low pressure, high pressure, what divergence and what convergence means. I'll drop in another little image for a second. It gives me a chance to erase, and then we're going to look at this from a kind of a top view and talk a little bit about wind directions around both these systems. Okay, so we're back. And so what's the next piece of this puzzle between highs and lows and how it drives our weather? All right, so again, we're going to put a high pressure here in blue, cold, low pressure over here, red, warm. Part one. Part two. So you've probably seen this. These little lines. These lines are called isobars, and they're lines of constant pressure or equal pressure. And an isobar, and I'm running out of ink here, so I'll change colors. An isobar, lines of constant barometric pressure. They're divided by four, there's always 4 millibars, MBs, between each isobar. The more isobars in between a high and a low, the more intense the change. So when you see them packed closely together, they think of that's going to be a very steep decline and generally more dramatic changes in the weather. Pressure, like fluids, flow from high pressure to low pressure. Right? So coming out of a high pressure to low pressure, air wants to move in this general direction. It's moving downhill to fill this void, because you remember back to that vision, low pressure is rising air going up, so it's creating a vacuum or a void almost. Think like sucking through a straw. So air generally moves, air moves from high pressure to low pressure. All right? So you think about it, and then we have that nasty old Coriolis force impacting this as well. So as it's moving in this direction, and it could be coming in from all directions, kind of through, as it's moving in from different directions, the air moving into a low, moving into a low, moving into a low. Coriolis force is turning it to what direction in the northern hemisphere? It's turning it to the right. So as it comes into the low, it diffracts to the right, it diffracts to the right, it diffracts to the right. It moves to the right, it moves to the right, and moves to the right. And if you look at that, there in Y, we have the counterclockwise rotation of air moving into a low pressure. That is why it's called counterclockwise, that's why it's called cyclonic. Oppositely, if it's moving away from a high pressure system, in general directions. And again, we'll have another video on winds to talk about this a little bit more detail. As it's moving out away from a high, again, it's moving out and turning to the right, moving out, 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 turning to the right. There you go. So you have this clockwise rotation around a high. So know that isobars are lines of equal barometric pressure. They're separated by every 4 millibars. That wind around a high pressure, because winds flow or from high pressure to low pressure, move about it in a clockwise fashion in the northern hemisphere. In a low pressure system, in a counterclockwise fashion, also known as cyclonic, known as anticyclonic. So if you were labeling these millibars, let's just say hypothetically this is 1,000 millibars. So the next one's going to be what? 996, 992, and then 988, and 984, and this one's going to be 1,004. Sea level pressure, 1,013.25 millibars is standard sea level pressure. You should know that. Generally, though, lastly, is that with wind direction, a couple of things. The wind direction from high to low is a combination of the direction of the gradient, of the pressure gradient. If a wind is traveling directly or perpendicular, if you will, to a line of an isobar, a line of constant pressure, that's called a gradient wind. So it's moving along the pressure gradient. If a wind, and depending on how tightly these are packed or how loosely these are packed, impacts the gradient wind, what direction. If a wind is traveling along the line of an isobar, it's called a geostropic wind. So gradient wind from high to low, geostropic, along a line of equal pressure. Normally it's a combination of that. It's a combination of the pressure gradient along with the Coriolis force, and then there's a friction or drag that's always opposite, directly opposite the Coriolis force. So the forces that impact wind direction are the pressure gradient, the Coriolis force, and friction. All right. And if it's a gradient wind along lines of pressure, a geostropic wind along the line of a isobar or equal pressure. So that's highs and lows. It's a little bit how it impacts wind direction, how air moves, what isobars are, no sea level pressure, and we'll be back sometime soon. Hope to see you back. Thanks again. This is Mr. Music with Mr. Music's Weather Whiteboard.